So hello and welcome everyone, my name is Jay Dalsaniya, and in this video we are going to solve the problem that is triplet family. So first of all, let's try to understand what this problem statement is trying to say. So here the question is saying that you will be given an array of integers and you are supposed to find out whether three numbers are such that the sum of two elements equals the third number. Okay, so you are supposed to see that whether you are able to find out three triplets in which the sum of two is the answer of the other one. Matlab कि here if we see 1 2, so if we add 1 2 and if we are looking at this triplet 1 2 and 3, we know that sum of 1 and 2 is equal to 3. So in this array we can find out the triplet, so the output comes out to be 3. So now let's try to see how we can solve this problem. Okay, so I'm taking an example of the first test case that is given to us 1 2 3 4 and 5. Okay, so here in this one I can see there is one triplet 1 2 and 3, and hence the output for this one comes out to be true, that yes, we are able to find out a triplet where the sum of first two is equal to the last one. Okay, so how can we solve this problem statement? I hope you have understood the problem statement. So now let's try to understand or brainstorm on how we can solve the problem statement. Now let's take, this is our approach over here. So here let's say 5 2 1 3 and let's say 6. So if let's say this is an unsorted array which is given to us. Now here we are going to use two pointers approach in order to find out whether we can find the two numbers whose sum is equal to the current number. Okay, so in order to apply the two pointers approach, I'm going to sort the array. Arrays sort. Okay, so after sorting, what do we will be getting? We will be getting 1 2 3 5 and 6. So this is the array that we will be getting 0 1 2 3 and 4. Now here tell me one thing, if the array is sorted, should I start from the left hand side or should I start from the right hand side? If we start from the left hand side, let's say if I'm looking forward to find out whether I can find two numbers whose sum is equal to 1, will you be able to find out those numbers in this part? Obviously not, because this array is sorted and all the numbers that are greater than 1 will be appearing on the right hand side of this one. So what you should do, you should take the key element as the last element and you should apply the two pointers approach over here. Okay, so let's see if we can find out two numbers that will add up to 6. So I'll apply a two pointers approach. So let's say this is my two pointers. So this is my I and J and this is the current element K. So I can see that 1 plus 5 is equivalent to 6, and luckily 1 plus 5 was equal to 6. Hence we can say yes, we have found a triplet. If this was not true, then what we will be doing? We'll be incrementing the value of, we will be decrementing the value of K. Now let's say I'll change the value of the last number. I'll change the test case to, let's say from 6, I'll change it to 10. Okay. So last number is 10 over here. Now I want to find out whether I can see two numbers whose sum is equivalent to 10. So I'll apply a two pointers approach. So this is I and this is J. So can you say that 1 plus 5 is equivalent to 10? No. I can say that 1 plus 5 is actually what? it is less than 10. So that means that I need the sum to be increased. So whenever you want to increase the sum, you will increment the value of I. Okay, so I is equivalent to 2. Now 2 plus 5 is less than 10 again. Yes, so again increment the sum, so 3. So 3 plus 5, what you will be getting? You will be getting 8. It is again less than 10. So again I need to increase the sum. But I and J cannot be same. You need a different number. So I cannot find out two numbers whose sum is equivalent to 10. Now I should look for the other number. So I will decrement the value of K. So K will be over here. Again two pointers approach, I over here and J over here. So now tell me, is I plus J equivalent to so-called 5? 1 plus 3 is equivalent to 5? No. It is what? It is less than 5. So I need this sum to be increased. So I'll increment the value of I. So now tell me 2 plus 3 is equivalent to 5? Yes. So this means that we have found a triplet 2, 3 and 5 according to the requirement, and hence the output for this test case comes out to be true. Okay. So here we will be sorting the array and then we are going to apply the two pointers approach. So let's try to see the implementation for the same. Okay, so in this triplet family, I have implemented the code in Java, but you can implement the same thing in other languages as well. So here I have taken the length of the array as n, then I have sorted it. So sorting will take around n log n time. Then I started the loop from the last element and I'm going till index number 2, because I need two elements on which I can apply two pointers approach. So k will be having the smallest value as index number 2. I equals to 0 and j is equal to k minus 1. Simple two pointers approach. If the sum is equal to array of k, then return true. Else if array of I plus j is greater than k, then you're supposed to decrement the value of j. And if the sum is less than array of k, then you're supposed to increment the value of I. And if the answer does not exist, then this line number 18 will not return true. That means answer does not exist, so you are supposed to return false. Okay, so now let's say to submit and see whether this gets accepted or not. And we can see that the problem has been successfully submitted. So talking about the time and space complexity, the time complexity will be n log n plus the two pointers approach, that is taking n square. So overall time complexity will be n square, and the space complexity is constant over here. So we have met the expected time and space complexity. So this was the solution for the question triplet family. I hope you really enjoyed this solution, and if you really enjoyed the solution, then do hit the like button and share this video solution with the friends as well. So that was it for in this video. Till then, keep coding. I will be seeing you in the next video. Thank you for watching.